So, if I go into Schoology, I just don't understand how to do this. And you go into day 1, there's that flashcards. So there's a cube root, correct? Click on that. Use the graph, whatever you want. It's got a card there. Click the card to flip. So there's a cubic root. Asks you to do all that, correct? Then if you want to know the answers, you just hit, how do you get it to turn here? Just click it again, right? There you go. There's the function. It's a cubic root. Domains, all real numbers. Range is all real numbers. It's got 1, 2, 3, 4, 5 points. Does that make sense? So that'll be your nice practice tonight. Does that make sense?
Yeah.
I'm here to please. Okay? Oh, I thought that was pretty cool. You guys might not think so. Okay. Parent functions. Use the parent graph, y equals x squared. So y equals x squared is which function? What's it called? Quadratic, correct? Agreed? Agreed?
Yeah.
So if I wanted to graph it, 1 squared's 1, 2 squared's 4, 3 squared's 9, correct? And vice versa. And I draw my graph. Okay? If I wanted to graph x squared plus 3. So if I go into Desmos and put in y equals x squared. There's the parent function, correct? Everybody see it up there? Right? Let's do the next one. What is it? Y equals what? X squared plus 3, is that it? Okay? So y equals x squared plus 3. So what's it do to the graph? Shifts it up 3, correct? Up 3. That's called a vertical shift. It's shifting it up 3. Okay? What's the next one? Y equals what? Minus 4. Okay? What's this one here do? Shifts it where? Down 4, doesn't it? It's a vertical shift down 4. Any questions on that? So, first one we had up to 3, correct? 1, 2, 3. Right 1, up 1. Right 2, up 4. Right 1, 2. That's off the page, isn't it? So there's that one. So I did that one in green. and the other one I do in blue, -4. So I go down 1, 2, 3, 4. Right 1, up 1, right 2, up 1, 2, 3, 4, right 1, 2, 3, and over 1, 2, 3, 4, 5, 6, 7, 8, 9. Does everybody understand why I go to the right 1? What's 1 squared? 1. Right 2, what's 2 squared? 4. Right 3, what's 3 squared? 9, correct? And then I use my symmetry. 1 unit over, 2 units over, 3 units over. It's symmetrical about the y-axis, isn't it? Correct? So there's that one there. Okay? The next one, what is this one here called? Square root function, correct? How many points do you have on a square root function?
4.
4. The one on the left is a quadratic function, correct? So let's graph the square root function. I'm going to graph it in black. What's the square root of 1? 1. What's the square root of 4? Square root of 9? 3, correct? I like to do the parent function dashed. That tells me it's the parent function. Make sense? Let's do this one here in green. So what are we going to do to that graph? What are we going to do with all the points? That right there tells me. What am I going to do? Up 2. Up 2. So I take each point. This point here, up 2. This point right here, up 2. This point here, up 2. That point there, up 2. And draw my new graph. Does that make sense? You see why it's important to know what the parent function is. What's the next one? What are we doing to the next one? Down 5. So from the parent function, I go down 1, 2, 3, 4, 5. That point, 1, 2, 3, 4, 5. That point right there, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Does that make sense? Questions? Better ask if you've got a question. Does everybody see I'm getting these? 0, 0 is the first point, right? What's square root of 1? Square root of 4? Square root of 9? And that's all you need right there, correct? It's going to be half of a C, isn't it? Okay? Okay, so then it goes on to say vertical shifts. This means up vertically by K, doesn't it? Okay? This one here means down vertically by K, doesn't it? Everything outside the parentheses deals with vertical, deals with Y. Okay? Anything that's inside the parentheses deals with X. Outside Y. Inside X. Okay? All right, next. We got an absolute value function, don't we? Correct? So I think we got to go to the next page to get the graph, don't we? There it is. So we're dealing with the absolute value function. Agreed? I'm going to write it right here. Okay? Right here. 0, 0, 1, 1, 2, 2, up 1, over. Everybody see how I graphed the parent function there? Okay, now let's go back to Desmos. If I can find it here. Okay, there it is. So let's get rid of these, get rid of these. So the first one was absolute value function, right? So let's see here. I'm going to get rid of that. So does it have absolute value anywhere? Functions. Under where? There it is. Sorry. Don't use that every day. Okay, there's absolute value parent function, correct? Okay, looking at the next page, it's y equals what? X plus 1. This is tricky. So everybody see I'm getting x plus 1. That was on the opposite page, wasn't it? Okay. So x plus 1, what did it do? To the left 1. When it's inside, it's an imposter. When it's inside, it's an imposter. You hear what I just said? So you think you're going right 1. Don't believe that imposter. You're going which way? Left 1, aren't you? Correct? Everybody hear what I just said? And then what's the other one here? Minus 3, thank you. Which way did it send it? To the right, didn't it? Imposter, isn't it? You thought minus 3 was going to go to the left, didn't it? But it's an imposter. Okay, so let's go back. Okay, so one we did was y equals absolute value of, what was it? The first one? X plus what?
1.
1. So we just shift all those points to the left 1, right? Correct? And then what's the other one? Y equals absolute value of what? Minus 3. So we went right 3, right? Okay, so x plus h means you're going to shift left h horizontally. X deals with horizontally, or just left h, correct? X minus h means you're going to shift which way? Right h horizontally. It's an imposter, isn't it? Imposter syndrome. Okay? Okay, so we've worked on vertical shifts, which are up or down, right? They're on the outside. Then we just did horizontal shifts, which are in the inside. It's an imposter, right? Right, left. Now we're going to do reflecting. Okay? Reflecting. Now, a couple things. When everything that we're going to do today, the shape of the graph doesn't change. Okay? The shape doesn't change. The only thing that changes is it's shifting right or left, or if it's flipped. Does everybody hear what I just said? Now we're going to be flipping, which they call it reflecting. Same thing. You might hear me sometimes say flip. Okay? All right, so now we're doing a square root function again, correct? So let's go back to our Desmos. Okay, so we're going to do a square root function, correct? Where's the square root at? There it is. Square root of x, correct? Delete those. Okay, now, the next one is y equals what? Opposite. Okay, now listen. What did I say earlier? Everything on the outside deals with what? Y. So I'm going to negate all the y's, but when I negate all the y's, I'm actually reflecting it over the x-axis. Does everybody hear what I just said? I'm going to negate the y's, but I'm flipping it over the x-axis. So let's see what happens here. Let's see if Mr. Campbell's on his A game today. I haven't done a very good job the first 2 hours. Why wouldn't that give me a different color? I want a different color. Will it do that for me?
You gotta push through it.
Push what?
That.
Well, it's not doing it. Normally it gives me a different color, doesn't it? Anybody else know how to do that? I wonder if this dog will hunt.
Oh yeah.
Doesn't do anything, does
Maybe
it?
if you edit it and then click the color.
Edit?
Yeah, edit and then click the color and then maybe it'll let you manually change the color. Yeah. There you
That's what I like to see. Man, you guys are good. I learned something today. I don't use Desmos. I like to use this bird right here. This old head. I told you I went to the doctor the other day, right? Got a CAT scan. Been having headaches. You know what they found?
What?
I didn't have a brain. Nobody even got that. If you can't laugh at yourself, you got issues, right? I'm a very self-deprecating person. All right, I do love myself, but I like making fun of myself. Does that make sense? Correct? I laugh every morning. I wake up and look in the mirror. Okay, now I look here. What's the next one? Is the negative on the inside? Is that correct? Now, everything on the inside deals with the what? X. So I'm going to negate the x's, but in reality, I'm reflecting it over the what? The y. Okay? So let's see if I'm on my A game again. I need to get a different color for this. This dog just is not hunting. Oh, it's not anything in there. Oh, sorry. Sorry about that. Can't have fun. Is that right?
Yeah.
Let's do a different color here. I'm kind of into Christmas. Is there any green? Okay, so the negative is on the inside. It flipped it over the y-axis, didn't it? Did it?
Yeah.
Yep. Now I want to show you something. When it's reflected over the y, that means we negated the x's, correct? So look at this point right here. What point is that? 1, 1. This point here should be negative 1, 1, right? And it is, isn't it? Correct? When you reflect over the x, this is 1, 1. Agreed? This is going to be 1, negative 1, isn't it? Does this make sense or not?
Yes.
The biggest thing is, remember, outside y, inside x. And inside you get an imposter. Okay? Does that make sense? Okay. All right, let's see where I'm at here. See if I can get back where I was at. I'm just good enough at technology to get in trouble. Okay, so let's look at this one here. So let me go ahead and graph this for you. At the beginning I did the parent function. Square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. Right? So why do I do a dash? Because that is the what? The parent function. Correct? And then we did y equals negative on the outside, the opposite of square root of x. That's on the outside, so that reflects the y's, correct?
Yes.
So it's going to be down below. Agreed? So this point is here now. That's the same point. This point is here now. 4, 2, 9, 3. Okay? Does that make sense? And then this one here, we're negating the x's, which means I'm reflecting it over the y, correct? So this one here is here. Take that point, reflect it. let's see, 1, 2, 3, 4, 2, 9, 3. Excuse me, does that make sense? Or no? Okay. All right, what's this one here? B. So this one here was the square root, correct? Isn't this an exponential? Weren't you guys supposed to memorize these? And remember, with the exponential, we're always going to use y equals 2 to the x, correct? We're always going to use y equals 2 to the x. We're not going to use y equals 5 to the x or 1/2 to the x. We're going to use 2 to the x every time. Okay. All right, so let's go back to our Desmos. And so I'm going to go y equals 2 to the power of x. Okay, there's our parent function, correct? Now what's the next one having me do?
Y equals -2.
Is a negative on the outside, negative like this?
Yeah.
2 to the power of x. Okay, the negative was out in front, correct? Right? Which means I'm negating all the y's, correct? So it should be reflected across the x, is it?
Yeah.
It is, isn't it? Agreed? Now let's look at the next one. Okay, that one there, negative x means it's I'm negating all the x's, right? So it's reflected across the what? Y. If you did better in geometry, this unit's probably going to be good for you because you can picture it more, right? That's what geometry is. Agreed? Geometry, like me, I was not a good geometry student. This is kind of hard for me. But I do it so much, I've gotten decent at it. Okay, does this make sense so far? The negative out in front negates the y, so it reflects it across the x-axis. The negative's with the x, then it's going to be, you're going to negate the x and reflect it over the y. Okay. I don't need to put that graph on your notes, do you? You already have it, don't you? Okay, I can here. 2 to the 0 is 1, 1/2, 1/4. 1 is 2. 2 squared is 4. 2 to the 3rd is 8. So that was our parent function, right? And then we negated it, the negatives out in front, so I negated all the y's, so it's over the x-axis. So I'll do this one in green. Correct? So here, correct? Here, here. 2 to the 1st is 2. 2 squared is 4. 2 to the 3rd is 8. So there's that one. Okay, this one here, let's do in red. So now we're going to reflect it across the y-axis, correct? So that point's going to be there. That point's going to be there. That point's going to stay the same. There. That point I'm going to go over here. That point I'm going to go over here. Is this making sense? Okay. So, negative out in front is a reflection across the x-axis. Here I negate the x, so it's a reflection across the y-axis. Okay? Notice we've done nothing at all with shape, have we? Correct? We've moved them right, left, up, down. We've reflected them right, over the x-axis. We've reflected over the y-axis. We haven't done anything with shape. That's what we're going to do next. Translations and reflections only change the position or location of the graph. The general size and shape of the graph is unchanged. The next type of transformation will change the shape. Okay? Okay, so let's graph this parent function real quick, and we can do it. I'm going to do it here on my absolute value function, right? It's V-shaped, agreed? Okay, so the 3 is on the where? Inside or outside? Outside. Okay? So what does that mean I'm going to do to all the y's? Multiplying by 3. Okay? So instead of 1, 1, it's 1, 1. 3. Correct? I'm not moving it anywhere, am I? So instead of 1, 1, it's 1, 3. Instead of 2, 2, it's 2, 6. Instead of 3, 3, I'm going to go 3, 9. Everybody see what I did there? And I'll do the same thing with the other ones. And I'm going to draw my new absolute value. Does anybody see an easier way to do it? Anybody see it at all? What if I wrote it like this? Isn't that a line? Slope of 3, y-intercept is 0. How many remember y equals mx plus b? Correct? Okay, there's my y-intercept. I go up 1, 2, 3 into the right one. Up 1, 2, 3 to the right one. That's the right side, and then of the absolute value. To get the left side, I just negate. Instead of, I go up 3, but instead of going right 1, I go which way? Left 1. You can do it that way too. Does everybody hear what I just said? Y equals mx plus b. This is the slope. Okay, what do you think 1/3 is going to do to it? I'm going to multiply all the y values by what? 1/3. A quicker way to do it is just do the slope. Okay? So what's the slope? 1/3. So I'm going to go up 1 over 1, 2, 3. Up 1 over 1, 2, 3. Up 1 over 1, 2, 3. Everybody see what I did there? True, just like a line. And then I draw my graph. Up 1 to the left 3. Up 1 to the left 3. Up 1 to the left 3. What do you notice about the one in blue relative to the parent function? What has it done? Get wider, didn't it? That's called a vertical shrink or compression. What it means by vertical shrink or compression, it's not going up as quick, is it? Horizontally, it's getting wider, isn't it? But vertically, it's getting wider. But this way, it's stretching, isn't it? But so vertically, it's getting compressed or shrunk. The one in green is getting skinnier, isn't it? Relative to the parent function. We call that a vertical stretch. We had a friend of mine in high school, his name was Stretch Cunningham. Why? Because he was about 6'8" and he weighed about 5 pounds when he was wet. He didn't even cast a shadow, he was so skinny. We called him Stretch. Okay, so vertical stretch and compression shrink. It is a vertical stretch if your number out in front, this number right here, absolute value is greater than 1. Notice, 3 is greater than 1, isn't it? Correct? Absolute value, because the negative out in front is going to be the reflection, isn't it? So it's always the absolute value. Now, so that's called a vertical stretch. It is a vertical compression or shrink. They mean the same thing. If A, the absolute value, is between 0 and 1. It's going to be a fraction or a decimal. So this second one was 1/3, wasn't it? Correct? Which is between 0 and what? 1. So that is called a vertical compression or shrink. The other one is called a what? Stretch. Okay, this one here is a line, isn't it? Correct? Slope of 1. I'm going up 2 over 1 instead of up 1 over 1, okay? This is a line, isn't it? So isn't this a linear? Correct? So let's draw our line. That's our parent function. I didn't dash it, which I probably should have. 4x. What's the slope of y equals 4x going to be? Slope of what? 4, correct? So I'd go from that point up 1, 2, 3, 4, and over 1. Or what could I do with all those points? Shift them up which way? Instead of 2, 2, it'd be 2 what? 8. Does that make sense? I'd multiply them all by what? 4. Or I could just do the slope, correct? Does everybody hear what I just said? Let's check it. This is 2, 2. Let's go 2 up to 8. So, up 4 over 1. Up 1, 2, 3, 4. Ooh, it works, doesn't it? Everybody see that? So I'm going to draw my line here. I'm going to do my best. There's that one. Now I'm going to go up 3/4 as much, aren't I, for the second one? So I'll multiply all my y's by 3/4, or I can just do my slope, correct? So what's my slope? 3/4, is that right? So this is a vertical shrink or compression, correct? So from here I'm going to go up 1, 2, 3, up 1, 2, 3, and over 1, 2, 3, 4. I'm going to do it in red. Everybody see where I'm getting the slope of 3/4? Go up 3 over 4. Up 1, 2, 3, and over 1, 2, 3, 4. It's kind of hard to multiply all those y values by 3/4 because you're going to get a decimal, aren't you? Correct? So I just do the slope. So this was a stretch. This one here was a stretch, right? This one here is a what? A shrink or compression. Agreed? Okay. Order. You need to translate horizontally before reflecting over the y-axis, and you need to stretch, shrink, reflect over the x-axis before you translate the graph up or down. Okay? So you want to do all reflections first before you start shifting. Okay, so it says here, name the parent function. So on A, what's the parent function here? You got 6 of them. Somebody said it, I think. Isn't it quadratic? Isn't your parent function here y equals x squared? Correct?
Yeah.
So this is quadratic, isn't it? So this one here is going to be shifted which way? Left 2, correct? And which?
Down.
And down 3. You could plug it in Desmos and see the same thing, couldn't you? Correct? Quadratic looks like a what? U-shaped graph, correct? U-shaped graph. Okay, the next one. This one here is a what function? Some of you guys didn't do much studying last night. Absolute value function, right? Correct? So, what are we going to do first on this one here? Negative's out in front, right? Everything on the outside deals with the what? The y. So I'm negating the y's, which means I'm going to reflect across the what? The x-axis. So I get a reflection over x-axis. Okay? Agreed? And then I'm going to shift it which way? Left 5. Remember, imposter, it's on the inside. Okay, the next one is what kind of a function? Exponential, correct? All right? Is there any reflecting anywhere? What's that negative right there do? It's going to reflect it across the y-axis, isn't it? Because it's going to negate the x, isn't it? Correct? So it's going to reflect across y-axis because I'm negating the x's, right? It's going to be flipped over the x. And then what else am I going to do? Up 4. Is this making sense or not?
Yeah.
Kind of. Clear as mud. Okay, the next one. What function is this one here? Absolute value. And I'm going to shift it which way? Down 1. Because if it was shifted, everything on the inside deals with the x, doesn't it? Okay, what do we have next here? Whole bunch of them. Okay? What function's this one here? What? It's squared. It's got to be a what? Quadratic. Correct? Y equals x squared is my parent function. Agreed? Which way am I moving this one? Right 3, imposter, correct? Right 3, because it's inside the parentheses. Yes or no? The next one, what's the next one? Absolute value. Remember, it's y equals absolute value of x. Got a negative out in front, correct? So that means it's out in front, which means it's outside the parentheses, which means I'm negating the y, correct? Which means I'm reflecting over the x. Reflection over the x-axis. What's the next one? Absolute value again. I'm going to abbreviate. Negative on the inside. Okay, I didn't get through all of it, but you can get your homework done, correct? Good job today, kids.